Welcome to a little Saturday afternoon, Saturday evening, chapter 1.5 to 1.7. Not Friday problem. Well, they were assigned on Friday. They were presented to you on Friday, but it's Saturday. Detailed answers. So chapter 1.5 dealt with equations with variables on the both sides of the equal sign. So one of the mistakes that students make is they combine them without moving them. And we can't combine things because this is a tray over on the left side and this is a tray over on the right side, and they're separate of each other. So we want to consolidate our x's and consolidate our constants. So I'm going to move this negative 3x by adding 3x to both sides of that equation. These cancel, leaving me with 14 equaling 7x. These are like terms. We're adding 4x plus 3x, and now we're going to divide by 7, and we get 2 equals x. Nice, simple starting problem. Here we have not only variables on both sides, but we have constants on both sides. Always move the variable first. Always move the variable first. And I think we might see the reasoning behind that in these examples, so we'll see. I'm going to subtract 3a from both sides. I'm going to move the a's to the left side of the equation. 6a minus 3a is 3a minus 10 equals 17. So since I moved my variables to the left side, I'm going to move my constants to the other side. So I'm going to get rid of that negative 10 by adding 10. That leaves me with 3a equals 27. We'll divide by 3. And a equals 9. Another interesting problem, I'm really liking these problems as they grow. This is an interesting one. So not only do we have to move variables first, but even before that, we should simplify each side prior to moving. Okay, so these are on the same side of the equal sign, so we can combine them. They are like terms. We can combine these because they're on the same side. We can't combine it with this. This is on a different side. So 9, 5w minus 14w leaves me with negative 9w equals 12 minus 6w. Now I'm going to move my variables first, so I'm going to add 9w. I'm going to move the w's to the same side. 9 equals 12 plus 3w. Now I'm going to move my constants. Minus 12 minus 12. Negative 3 equals 3w. We'll divide by 3. Notice the negative here, so that simplifies to negative 1 equals w. Remember, simplify first. Simplify. So we're going to distribute. We can get rid of Chewbacca by distributing. 12 times b is 12b. And we have to distribute it to both of the terms inside of the parentheses. So 12 times 2 is 24. 8 times b is 8b. 8 times 5 is 40. Now we have variables on both sides and we have constants on both sides. So let's get rid of the variables first. I'm going to subtract 8b from both sides. 4b plus 24 equals 40. Now I'm going to move that constant to the other side. 4b equals 16. Divide by 4, divide by 4, b equals 4. Here is the interesting one. So let's distribute distribute, distribute, distribute. 6 times y is 6y. 6 times 8 is 48. 3 times 2y is 6y. 3 times -7 is -21. Here is the reason why we move variables first. Because sometimes they're going to cancel out. These cancel and these cancel, leaving you with a number statement. And this number statement is false. So when the variables cancel and you create a false number statement, it's going to be no solution. That is your answer. There is no number that can go into y to make the left side equal to the right side. So very important. When variables cancel, and you create a false number statement, the answer is no solution. Let's distribute 3/4 times 12c. The 4 goes into 12 3 times, so that leaves you with 3 times 3c, or 9c. 3/4 times -4. The 4 and the 4 cancel, leaving you with -3. 15c plus 15. Variables on both sides. Let's move the variables first. -3 equals 6c plus 15. Let's subtract 15. -18 equals 6c. Divide by 6. We have a -18 divided by a +6 is -3 equals c. Distributing. 11 times 4p is 44p. 11 times 4 is 44. Minus 4p equals 4 times 7 is 28p minus 7. Remember, simplify. We have like terms on the same side of the equal sign. We must simplify that. That gives you 40p plus 44 equals 28p minus 7. Move the variables. Minus 28p minus 28p gives you 12p plus 44 equals -7. Let's subtract 44. 12p equals -53. 51. Ugly. Let's check and make sure. 44, 4, -4. That simplifies to 40. That's 28. I made a mistake. See, I got something weird, and I just didn't go on. I actually took the time to go back. That's actually -28. Silly Mr. Mac. Everybody makes mistakes. And that's -28. So we actually end up with 72. 72, which is a much better number to divide by 12. And p equals, is it better? No, maybe it's not better. That's 2. That's 72. All right, let's check and make sure again. Let's just not rush things. That's correct. That's positive. That's positive. That's negative. That's good. That's 12. That's that. 2, carry the 1 is 6, 72. Okay. So 12 doesn't go into 72, but 3 goes into 3 goes into both of those. 9 goes in there. Yeah, 3. 3 goes into negative 72, negative 24 times, and 3 goes into 12. Oh, hello, 6 times. 12 times. I don't know why I was tired. I'm tired. I cleaned all the windows of my house today. I saw negative 72 and 12, and I was like, yeah, that goes in, but then I couldn't think of the number. And this is what happens. Sometimes your brain shuts down for a second. And because I stuck with it and then simplified it to a more reasonable number that was more familiar to me, I was able to get there. So that is a goofy one, but a good one to learn from, because everybody tends to make silly mistakes. 3 times 2D is 60. In fact, I made a couple mistakes on that problem. 3 times negative 8 is negative 24 equals 11D is here. Negative 18 times D is negative 18D. And negative 18 times negative 3 is positive 54. Positive 54. 18 times 3. That's 24. Yeah, 54. Takes 2 seconds to show your work and check your work. All right, let's combine like terms. They're on the same side, so we will simplify that. 6D minus 24 equals negative 7D plus 54. That is correct. I'm going to add 7D. I'm going to move my D's to the left side. That gives me 13D minus 24 equals 54. Add 24 to both sides. And you get 13D equals 78. And does 13 go into 78? 13 doesn't go in 4 times. D, 13 go into 78. What would we do? 13, that gives me an 8. Well, 6, yeah, 6. 3 times 6 is 18, carry the 1, 78. So that goes in 6 times. Another. Took 2 seconds to just multiply and test that number. Distribute, 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 distribute. 5 times 4 is 20. 5 times R is 5R. Half of 40 is 20. Half of 10R is 5R. Move the variables first. Move the variables. 20 equals 20. That makes a true statement. The variables cancel. It makes a true statement. So it is infinitely many solutions. That is the answer. We can also have identity. That is also and then all real numbers. Now, if you can't write infinitely identity number solutions. You either have to have infinitely many solutions, identity, or all real numbers, not part real infinitely many identity solution numbers. If you're going to pick one, pick one. And don't give me more than one answer. Just give me one answer. So we need to remember, I want to do this. I wanted to do this. I wanted to do this. I wanted to copy this. Copy. And then I wanted to paste it. What? I wanted to paste it. Ah! That was silly. Not that. Oh, whoops. I do want that part. just want to erase this. I want to erase this. And I want to write this. When you create a true number statement, the answer is infinite many solutions. Good. That's a good one. Okay. We're going to have to distribute this. 3/5 e minus 6 equals negative 2/5 e. Now the 5 and the 10 cancel, the 2, so that's positive 4. And then we lump on that negative 7. Let's combine like terms. We want to simplify each side prior to moving. Positive 4, negative 7 is negative 3. Let's move my variables to the left. That's going to give me 5/5, or it's just going to give me e. Let's add 6, and e equals 3. That wasn't so hard. All right, 1.6. Now we're dealing with absolute value. And what this is saying is, remember, whatever this is in the middle, in this box, needs to have a distance. When I take the absolute value, it has to have an absolute value of 10. So this thing can either equal 10, because if 10 was in here, the absolute value of 10 is 10, or this box needs to equal negative 10, because if negative 10 was in here, the absolute value of negative 10 is also equal to 10. So when we replace that squiggly with what's in there, we need to write p minus 3. And so what's behind that squiggly box is p minus 3. We're not taking the absolute value of this. We don't make this positive. That's a common mistake. We write two statements. We write what is inside the absolute value equaling a positive or negative value of that. Now we solve it. So we'll add 3 to both sides, and we get p equals 13. We'll add 3 to both sides, and you get p equals negative 7. Those are the two values that can go in here to make this equal to the absolute value of 10. So when I write my solutions, I'm always going to write them in solution sets. So write, no, that's not how you spell write. Write solutions in numerical order and in braces. And braces are solution sets. Good. All right, so we're going to write two statements. We're going to write what's inside. Negative 2k can equal 6, or negative 2k can be equal to negative 6. We'll divide by negative 2. We get k equals negative 3. We'll divide by negative 2. And we'll get k equals positive 3. So my solution set is going to be my two solutions in numerical order. So this is a trick one. This one you have to red flag. That's a red flag. Notice that we have an absolute value that equals a negative number. That's never going to happen. An absolute value will never produce a negative number. because absolute value only has positive distance. It's saying, hey, this distance equals -2. That is no solution. That is a no. You can't have a negative distance. We can have fractions. Q over 5 equals 3. And the other statement would be Q over 5 equals -3. We'll multiply both sides by 5 because Q is being divided. The inverse of dividing 5 is multiplying by 5. Q equals 15. And then we will multiply both sides by 5. And Q equals -15. So we get -15 and +15. Now, important, when we have absolute values and things are happening to it, we must isolate the absolute value. First, before writing the positive and negative value. So we have to -9 minus 9. We get the absolute value of -a plus 2 equals -3. Red flag, absolute value cannot equal a negative distance. So this answer is going to be no solution. You can't have an absolute value equal to a negative number. Now, we haven't isolated. We got to isolate, so we got to get rid of that 3. That 3 is multiplying, so we're going to divide both sides by 3. We have the absolute value of 4 minus 3m equals 10. Write this statement. Don't start writing the two statements until you've isolated the absolute value. Once it's isolated, now you can write both statements. 4 minus 3m can equal 10. 4 minus 3m can equal -10. And now we'll solve it. So we'll get rid of things being added and subtracted first. -3m equals 6. Divide by -3. And m equals -2. We will subtract 4. -3m equals -14. Divide by -3. And m equals positive 14/3. So you must simplify those double negatives. You can't simplify 14 over 3. And we're going to write it in numerical order. -2 and 14 over 3. Let's get rid. Yes, this is equal to a negative number, but it's not isolated yet. We got to get rid of that -4 that's multiplying by dividing by -4. Now we get the absolute value of 5g minus 12 equals 3, and it's okay. Absolute value can have a positive distance. So we're going to write two statements. 5g minus 12 equals 3, and 5g minus 12 equals -3. Let's add 12 to both sides. 5g equals 15. That's a 12 right there. Sorry, that's not a very well-written 12. I'll erase it and take my time and write it properly. And now we're going to divide by 5. And g equals 3. Let's add 12 to both sides. Almost wrote a bad 12 again. 5g, that's a horrible 5. 5g equals 9. We'll divide by 5, divide by 5, and g equals 9/5. Okay, let's write it now. 9/5 and 3. Which one's smaller? The smaller is 9/5, and the bigger is 3. Numerical order. Let's subtract the 9. We're isolating the absolute value first. And now we'll write our two statements. X minus 3 equals 21. X minus 3 equals -21. Let's add 3 to both sides. X equals 24. Let's add 3 to both sides. X equals negative 18. Numerical order, negative 18, 24. Two things are happening. Something's adding and something's multiplying. So let's get rid of that addition first. And somebody asked, hey, Mr. Mac, 2d minus 6 equals 0. Can it equal 0? Yeah, of course it can. Absolute value can have 0 distance. We'll divide by 3 because we're not done. We haven't isolated it. 2d minus 6 equals 0. Now this is interesting. Is distance, if it has a distance of 0, it doesn't have a left and right. So we're actually only going to write one statement. You can't do positive 0 and negative 0. Those are the same numbers. So you're actually going to have only one solution here, which is very rare with absolute values, but it's good. They're showing you all the weird ones. Divide by 2 and d equals 3. So we would write it in an absolute value, or in a solution set. Minus 4, 7 times the absolute value of 2c minus 6 equals, what's that, 28. Divide by 7. Absolute value of 2c minus 6 equals 4. Let's write those two statements. 2c minus 6 equals 4. 2c minus 6 equals negative 4. Let's add 6. 2c equals 10. Divide by 2. Divide by 2. C equals 5. Let's add 6. Add 6. 2c equals 2. Divide by 2. Divide by 2. C equals 1. Solution set is 1, 5. Again, not my best 5 I've ever written in my life. So let's take the time to rewrite it so everybody can understand it. All right, last section, chapter 1.7, solve the literal equation for y. So we're going to isolate y. Something is adding it, so I will subtract. The inverse of adding 5x is subtracting 5x, and you get y equals negative 5x plus 17. Now remember, when we write expressions, variables, we can make those dots, dot, 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 dot. When we write expressions, this is an expression. It's the right side of the equal sign. An equation is two expressions equaling each other, I think is the definition. When we write expressions, variables come before constants. So we're going to write our variable before our constant in that right side of the equation. We're isolating for y. We're going to get rid of things being added and subtracted first. For y equals 36x plus 28. Now we're going to divide, and when we divide one side, we have to divide everything. If we're going to take a fourth of the right side, we got to take a fourth of each of the pieces. So y equals 9x plus 7. We're getting y by itself. Make sure you know which variable you're isolating. And in this case, we're going to align it. We only do it one side to the right, one side to the left. And if we have like terms, we're going to align those. So you get 8x minus 24. That's a bad 2. 24 equals 8y. And now we're going to divide it by 8. And again, this time we're going to do everything by 8. And you get x minus 3 equals y. And that's the best way to write it. If you want to rewrite it after the fact, if you want to write y equals x minus 3, that's okay. I don't care, but I would have accepted that. That's a correct answer. We want to get y by itself. Let's subtract 6. We're going to match it up with its like term. 1/3 y equals, and I'm going to write my variable first because I see that I would have written 4 plus 12x, and I'll just rewrite it better. Now, I'm not going to divide by 1/3. Whenever a fraction is multiplying, we multiply by the reciprocal. The reciprocal of 1/3 is 3. And when we multiply that right side, remember how we had to divide everything? Well, we have to multiply. If we're going to triple everything, if we're going to triple the right side, we got to triple both of these things. So y equals 36x plus 12. Now, in these, pay attention, we have to be aware. Now we're solving for x. Okay, remember, simplify first. If we can simplify before isolating, simplify. These are like terms. You get y equals 7x. Now we're solving for x, so now we can divide by 7. You get y over 7 equals x. Can we combine these like terms? No. These are not like terms. This is x and this is xf. So we cannot combine these, and we wouldn't move them because we want to solve for x. So how do we consolidate our x's? Well, remember trick-or-treating. These two kids came to my house, and they both have an x-ray machine. And I'm going to take that x-ray machine from both of them. If I take the x-ray machine, he's left with 5. If I take the x-ray, they're left with 10f. And so the x-ray machine is outside of the problem because this is the one I want to isolate. So we need to consolidate them somehow by factoring out, factor out a common x. And so if we factor it out, we get this, and now this is multiplying it. So if I want to get rid of it, I guess I should have done 10f first, but we'll just do this, 5 plus 10f, and we get d over, and I'm going to write 10f plus 5 equals x. That's the better way to do it. Okay, these are unlike. They both have an x, so I'm going to factor out an x. If I take the x from rx, that leaves me with r. If I take it from negative sx, we get negative s and p. Let's divide by r minus s, divide by r minus s, and we get x equals p over r minus s. That's a good one. Oh my goodness. All right. So let's isolate my x's first. Let's get rid of this n. Let's move the n to the other side. 3j minus n equals 4kx plus 7mx. Now they both have an x, so I'm going to factor out. I'm going to factor out that x, which leaves me with 4k plus 7m. And now we'll divide by 4k plus 7m. Divide by 4k plus 7m. Leaves me with 3j minus n over 4k plus 7m equals, what happened here? Did I write 1n? Oh, that might be my, is that an m? I don't know. That looked bad. 3j minus n, and that equals x. That's an excellent problem. And that's it. How much time did that take? That took probably about 45 minutes. Not bad. Very doable when you are familiar with the material and you recognize the problems because you've spent so much time practicing. You can be very efficient and you can get your work done really quickly. So putting in the time in advance, benefits you in the long term. Have a great weekend.